Hello everyone, I hope you guys are pretty well. So, as we were discussing our last topic, which was line integral, gamma function came to my mind. So, I thought that we should discuss about gamma function one day. Therefore, today in this video, we are going to discuss about gamma function only. So, we will start with its representation. The representation of gamma function is like this. This gamma function is basically an integration from 0 to infinity d to the power x minus 1 e to the power minus d dt. The value of this gamma function depends upon the value of x. If the value of x is greater than 0, then we will apply gamma x plus 1, which is equals to x into gamma x, which is also equals to x factorial. We will understand it further with the help of an example within a few minutes. If x is equals to 0, then we will consider the value of gamma as infinity or undefined. But if x is less than 0, so we will avoid this case and not use gamma. We will think over some examples of the highlighted formula for x greater than 0 to reach out the depth of it. First of all, look over the x factorial. In this formula, which is highlighted with green color, we will always expand it as x, x minus 1, x minus 2, and so on. And these are simply multiplied with each other. That means x into x minus 1 into x minus 2 and so on. So let's solve gamma 7. If we compare this gamma 7 with gamma x plus 1, then we will get that this gamma is just equal to gamma 6 plus 1. This makes us helpful to apply the formula gamma x plus 1 to gamma 7. As a result, we can expand gamma 7 as 6 into gamma 6. Solving it further, we can write it as 6 into 5 gamma 5 by using the same formula. Similarly, we will solve the rest of this and get to the result. Furthermore, we will notice that we have used gamma 1 as 1. And why we have used it? Because this is fixed value of it. As we can see that we have solved gamma 7 by using this formula in these steps so many times. So now you must be thinking about the fractions as well, that these are also greater than 0. So can we apply the gamma function to these also? And to answer this, we will apply this formula to gamma 2 upon 3. After solving for gamma 2 upon 3, we will have something like this, in which we will come across 1 minus 1 upon 3. Okay? So it is clear that this formula is not applicable for gamma 2 upon 3. But it does not mean that we cannot use it on the fractions greater than 0. Actually, there is a condition to apply it, and this is that the numerator must not be smaller than the denominator. So, we will not use gamma function for 3 upon 5 also. This means that if we take gamma 3 upon 2, in which numerator is greater than denominator, then we will end up with gamma 1 plus 1 upon 2. As you can see that the formula is applicable to it, so you can pause the video to verify the answer. Also notice that we have used gamma 1 upon 2 as root pi. This is also the fixed value of it. One more formula of gamma function is there, and that is this. As you can see that this formula is only useful in integrating sin theta and cos theta terms. Here the value of m and n can vary. It is important to note here the values of theta, which are only 0 to pi by 2. Other values of theta should be converted first into 0 to pi by 2, and then we will move forward with the solution. Let's say we have a question in which we have to take integration from 0 to 2 pi. Now compare the value of theta in this term and in this term. The question here arises that how we are going to solve it. To convert 0 to 2 pi into 0 to pi by 2, we will consider a graph for it. These will be the required x-axis and y-axis. As we all know that the value of theta from 0 to pi by 2 is this much. So let's write it as theta equals to pi by 2, which is 90 degrees. If we extend this angle, then we get twice of pi by 2, which is equals to 180 degrees. Similarly, this angle is considered as 270 degrees and this angle is considered as 2 pi, which is equals to 360 degrees. This means that 2 pi can be written as 4 times of pi by 2. Now we can convert this integration in terms of pi by 2 like so. Now only part remained for us is to apply this simple formula. Here we have m and n as 1. So what do we get? We get this. We have simply substituted the values of m and n to the formula. Simplifying it further will result into this or this. The fixed value of gamma 1 is 1 and gamma 2 is also 1. Thus, we now have this after substituting the values, which after further simplification gets converted to 2. So guys, finally, we have the required value of integration of cos theta sin theta d theta from 0 to 2 pi as 2. But you know what? It has different value if we use substitution of sin theta as p. If you try it yourself, then you will find that the value of this integration is actually 0 and not 2. But with gamma function, it is 2. I hope you guys got the point. Try as many questions as you can related to this topic and ask your doubts in comment box below. So that's all for this video. Thank you. And if you like this video, then don't forget to like and subscribe to my channel. To get first notification of uploads, then click the bell icon also.